Today I'm going to talk about the projectile motion of facing off in lacrosse. So let's get to this video. At the point of this video, I'm going to explain what happens before the projectile motion for facing off in lacrosse. So right here, I drew a coordinate system so we know what direction we are in. And right now, we're going to focus on the ball. So right here, you can see me clamping down onto the ball with my head right here. And so we have a applied force right here, and we know there's a weight force to the ball. So right here, so equal opposite. So we know that since we have force applied to the ball and weight force to the ball, the normal force would be equal. So since we have applied force clamped down, normal force is increased due to applied force and weight force. Going on, this is a diagram I drew before the trajectory. So again, we have a coordinate system. So we're going in this direction of x. And what you see here is before the trajectory, the stick is at an angle right here. The stick is at an angle and is ready to exert kinetic energy to pop the ball off into the air. So right here, we could see that we exert force here. This would make the ball go in the air right here. So basically perform this kind of, this motion right here in the air, projectile motion. So now going on, we have the face off, the full diagram. Sorry, now for the y direction, it's in free fall, and we know that acceleration is going downwards in the j hat direction of negative j hat. So we have negative 9.81 meters over second squared. So right here, and x direction, so since it's free fall, it's a constant velocity, ax equals constant. Since it's not moving left or right, it's just moving constantly. So here we have basically the formula. So delta x over delta t. Right here, it's me facing off. I have a ball. So right here, you can see I exerted force to the ball. So it pops out of my stick right here. And right here, you can see the ball going in this direction. So explaining again, there's an angle of how we pop the ball so it can make this trajectory. Coordinate system is important. So right now, in this right here, I could explain it. Gravity acting on the ball. So this is gravity right here acting on the ball. That's what makes it go downwards. And right from this point, from A to B, the ball is in free fall. This is our right here is our VI for velocity initial. So just how much force I could applied. Let's say I apply 5. That would be equals 5m over s. That's how much velocity I applied force to make the ball fall in this motion. And right here, I did a kind of friction force mesh on the ball. So this is a mesh and this is the ball. So there's friction on two of those things. And I will explain here, there's kinetic energy here going to here. Kinetic energy decreases while potential energy increases. And from point here, potential energy decreases while kinetic energy increases. So right now I have a GIF, but I'll show you YouTube video. Let's play here. Right here, I could explain. So this triple FT is using projectile motion, catching the ball and shoots right there. So you see me facing off, I exert force on the ball. There, the ball goes in projectile motion, and I track it and I catch the ball. While you watch this video, I'm going to explain Newton's laws in face-offs. So first law of inertia. This law causes this law states that an object will remain at rest or in uniform motion unless acted upon by an external force. In the context of lacrosse, the lacrosse ball remains stationary until the players apply force to it with their sticks. The player's actions serve as an external force that overcomes the inertia of the ball, causing it to move. For Newton's second law of acceleration, this law describes the relationship between an object's mass, its acceleration, and the force applied to it. During a face-off, the players exert on the ball to accelerate in a desired location or direction. So the greater the force applied, the greater the acceleration of the ball. And for the third law, action-reaction law. So according to this law, for every action, there is an equal and opposite reaction. In face-off, when the players push their sticks against the ground to gain leverage and apply a force to the ball, the ground exerts an equal and opposite reaction force on the player's sticks. This reaction force allows the players to maintain stability and generate the necessary force to control the ball. Here's a bonus clip of me shooting towards the goal. I'm going to explain how projectile motion works in shooting. So projectile motion refers to the motion of a lacrosse ball after it's been thrown or shot into the air. This motion occurs under the influence of gravity, which acts as the only force affecting the ball's trajectory. So the path that the ball follows is called its trajectory. So when a lacrosse ball is thrown, it exhibits projectile motion with two main components, vertical and horizontal motion. So in the vertical direction, the ball experiences free falling motion, meaning its velocity decreases due to the acceleration of gravity. This downward motion is affected solely by gravity, pulling the ball towards the ground. In contrast, the horizontal motion of the lacrosse ball is independent of gravity once it leaves the stick. So the ball maintains a constant horizontal velocity unless acted upon by external force, such as air resistance or friction from the ground. So this horizontal motion allows players to aim and pass the ball accurately to teammates or towards the goal. I hope you enjoy my video. Thank you.